What you reading there, buddy?
I'm trying to figure out some more details about that ByteDance thing, where like the intern sabotaged a model.
Interesting. And how exactly did they do that?
Well, that's what I'm trying to figure out.
Oh.
They didn't release a lot of details, but as far as we can tell, the intern had access to like the training or something of ByteDance's internal model, and sabotaged it somehow, wasting all the researchers' time for like months. And I'm just thinking like, this would have been really easy to fish on a red team.
Yeah.
If an intern has that much access, like this isn't even like, you don't really need to be an insider threat for this. Like, if
you could just like fish. You can just send somebody a model file, right, or a link to a model file.
Yeah.
And if they run the model file.
Yeah. Now you have access to everything they have, and now you have access to their internal models as well.
Mm-hmm.
So it's like, it seems like it would be really, really easy to sabotage millions of dollars from a lot of these companies that are using AI just by doing simple phishing or something. And this guy screwed up because he wasn't very sneaky. Like he clearly, I don't know, I mean, he clearly earned his wages as an intern because they found him for wasting millions of dollars.
Yeah.
But if we were like doing a red team on ByteDance,
yeah,
you wouldn't need to even show your hand by like destroying things. You could
just like get access without the destructive.
Yeah, and then you could just keep your persistence inside of the model file itself through the backdoors. Because model files, I mean, they use layers of networks inside of the neural network ones have layers of networks inside of it, and you can just kind of inject your own backdoor into it that triggers when certain inputs are given to that model. And now the intern keeps his job, and you know, malicious things can be done in a production model that's used by 1 billion people a year.
Interesting. If only we had like a tool or antivirus scanner or something along those lines that detected this.
It's odd because I know that antivirus isn't going to detect a model backdoor.
Not. They're too big. They usually antivirus cap out at like 50 megabytes or something.
Yeah.
If I recall correctly.
Yeah,
performance reasons. But only there was something out there that could detect this kind of stuff.
Yeah. Too bad there's not. You just snuck in here, didn't you?
Yeah, I've actually been out of frame every single video.
Nice.
Just fully off to the side.
He's always been here. He's been here for 10 years, actually.
Just that or sometimes, just to the side.
But,
So here, Chris King with Protect AI, and we're going to talk a little bit about some of the tools that we've been building on the other side of the fence to actually do some defensive positioning against models and help protect against deserialization attacks. So like running arbitrary kind of malicious code, or when they get much sneakier, the kind of adversary, or I guess the neural backdoors that kind of get implanted in various layers, and why antivirus tools and other things are just ineffective to really address this threat.
We actually did like 6 months ago or something. We actually did some tests on injecting some very obvious malicious code into model files and found it was completely trivial to bypass. Like a base 64 Python exploit that is very obviously an exploit, like with the words meterpreter.
It's like,
hackme.com is in this payload, and antivirus just can't detect it in model files themselves for whatever reason.
It's a different file format. It's a very big file. Like there's a bunch of reasons antiviruses are finicky things.
Yeah. And there's also like a lot of these threats, they don't just exist kind of sitting statically necessarily inside the model. Many of them don't work until the model is actually up and operational and doing, an inference payload. So you're not going to have a situation where you can sit statically, looking at just an older executable and seeing the signature and be like, got it.
Right.
You're going to need an understanding of how to actually run and execute models and interpret what they're actually doing in order to figure out, is this a threat or not, or spot particular threats at, let's say, inference, for example.
Yeah, and that's where I think Guardian comes in.
Yes.
If I'm not mistaken.
I mean, you tell us.
Because we've actually been working on this for quite a long time, but since before ChatGPT came out, really.
Yeah, we've been doing a lot of work on model scanning, and it's not just us, but this has been a collaborative effort. We've seen, organizations like Hugging Face really start recently to advocate for, improving security for their users. But we've been exploring and evaluating models across the entire internet for the better part of the year, and we've seen, over 28,000 examples of these threats in the wild. They're doing things like stealing SSH credentials. We're seeing attacks where you're basically looking at cloud takeover. You mentioned, embedding content a few minutes ago in a model that could actually, potentially hurt other models within the registry. Those are attacks we've seen. Far more efficient to go that route. The ones that run at inference are especially gnarly because now you've got the compute resources in play of running the model along with the sensitive data for any kind of inference. So think healthcare information or financial information. Very easy to kind of abuse the compute power at hand and the sensitive information. So detecting those and then building a reliable system that gives you a chance to kind of meet users where they're at, how they want to leverage models, and provide that kind of protection.
Yeah, and the beauty of this is that the machine learning engineers and the models themselves actually have access to massive parts of the network because they have to. If you're training a model, it needs to have access to massive amounts of data, which may be sensitive customer data or massive amounts of compute power if you're training a model in-house. There's really two methods of employing AI in an organization. You can use the state-of-the-art models, which is an API endpoint, which does technically remove some of the responsibility of the security of that model from your organization. But you also can't do that if you're handling sensitive customer information because you're sending it off to a third party. So this would be a case where you're not using an API endpoint like Claude or something. You're doing it from a file that you downloaded from Hugging Face, GitHub, something like that.
Using a third-party model.
Right.
And you downloaded it from Hugging Face and you're using it internally, basically. That's it. Okay.
Exactly. And so if we think, in that like Hugging Face example to kind of really start there. So I'll start by just pulling up here a model card. This is a model that recently got in the press for some open source stuff around it, basically being used to do crypto mining. But Hugging Face is now reporting, hey, if you look at this on the site, anyone can see this when you're logged in or even public. They think that there's a security issue you need to be aware of, and you can kind of click to show files. You'll see a list of them. But if we browse to the actual files, what we can see is each one of these particular model files themselves that all kind of together form the model that goes into this application. Some warnings around unsafe and some extra information from Pickle. And so if we click this like unsafe banner, you see two things. Hugging Face themselves are operating an open source project called PickleScan. I mentioned Pickle a second ago. If you have models in that format, which again is really popular, it helps. It showcases here, hey, we think there are things like imports that may be unsafe. Specifically, the imports could also invoke remote code execution. They could be calling out to other libraries, just sitting kind of alongside with other models. It's really tough to get to the meat of it. So it's great that like Hugging Face is putting out this kind of warning right now. To your earlier point, ClamAV, this is not a traditional executable. There's no reason to expect the AV providers to really help here, even though it's a very solid like AV product. And what you also see is a banner from us, Protect AI, showcasing, hey, we've actually got a broader taxonomy of how to understand these findings. We scope it to the library that's in use. Like in this case, this is PyTorch. And you can read the full report here if you click it. And again, this is all public information on our tool, InsightsDB. So this explains, overview of the attack, key points about it, some background information you might find relevant. But it also has like how this attack could work and what remediation looks like, if you're seeing this on a third-party site. And this is information that we're just freely giving out. It's available to everyone that's using Hugging Face because we understand that while we focus a lot on enterprise security, there's a massive amount of work being done broader across researchers, hobbyists, enthusiasts, and we want to make sure that they have something that at least they can see information and know what they need to do to protect themselves. And one thing that I think it's like worth noting before we kind of start showcasing on anything that's like Guardian specific as far as the product goes is when we're reporting these kind of findings, here we're showcasing PickleScan and Protect AI, like both kind of reporting things. This is far from the only format that you really have to think about. There's GGUF, which is really popular with a lot of the chat models for templating. There's Safe Tensors, there's Onyx, there are a whole host of these formats. And we are working as a whole community of making machine learning safer and, using better formats. But we're, and you guys are familiar with the threat research, continually finding new vulnerabilities in these. Yes. And so if we look at, potentially another model here. So this is what I'm going to pull up now is Open Diffusion's sentiment check. So if I pull up the Open Diffusion sentiment check and we take a look at it, what we see first is, hey, this model, again, we see the security warning. We want to learn a little bit more. Now we see a protobuf file. So we'll click it to learn a little bit more here. And what we're showing is like, hey, this isn't a pickle file. It's serialized using protobuf. It's an entirely different approach. So PickleScan's not really able to help here. And this is one of the reasons why Hugging Face reached out to us and helped develop this partnership where our scans kind of showcase the model security posture.
Yeah, because all these attacks against the model files is not a traditional CVE. You can't say, oh, this is an XSS attack against the model file. We're essentially kind of creating these as we go. Yeah. At the core, most of it is backdoors and code execution as a fundamental due to deserialization.
Yeah.
But because there's all these different formats, GJUF, GJUF. I don't know. I have no idea how to say half.
It's gonna be like a GIF, GIF. I just want to GGUF.
It'd be one of those like ongoing debates.
You've got those binary formats. You've got formats like Llama that are actually executables. Like they're straight up programs.
Polyglot files.
Yeah, and then you have like JSON files with config files attached to them so that you know which weight is supposed to go where in the model. Like the complexity behind the model file attacks is quite extraordinary, and I feel like we're just right on the cutting edge of figuring out holistically what the threat surface is.
And that's another reason why like traditional like scanners like ClamAV don't necessarily pick up these threats, because like it's all format specific. So like you have to write regexes and file parsers specific to each individual format.
And sometimes it's specific to the library itself. So like Keras had a nasty one where they had you could inject a Lambda layer into a Keras model, which would just execute code, because you can do like class instantiation and stuff in Python. And what that means is if you download a malicious Keras model from Hugging Face or GitHub or whatever, then you can get code executed. And pickle scan, as far as I know, is not going to detect that.
Exactly.
Is that correct?
Yeah.
Yeah. So that's kind of where we're going with Guardian, is my understanding that we're trying to make the holistic defensive product that's not just pickle scanning deserialization.
Yeah. So we started this conversation around like this ByteDance example, which again, a lot of the details still emerging, but it is an indication of somewhere where the model that they had in-house or the ML resources they had in-house were a problem, and you need to build security controls into your model like ML ops process. So what we have here with Guardian is kind of these two use cases we think are really critical to delivering model security. And the first is basically to scan a model after you have trained it. So often you're going to train a model and you're going to take that resource and then you're going to put it in, let's say, S3 or your model registry, and it's going to sit there until some time where you're ready to like deploy that model and operate it, or maybe it sits on the shelf for a few months and some other team picks it up to use it later. So what we think is really important is when you're documenting these models, have a scanner in place that has a defined security posture, really digs deep to actually understand all the responses of those resources, and like puts the binary of the model itself and the security response together in your registry. So that's the first one. And just really quickly to show a demo of like what that looks like, I'll hop over to a different notebook I have here. And what we have is this Guardian scanner. And so with the Guardian scanner, what we're going to do is first basically use an environment variable I have behind the scenes that's going to reach out and decide where we're going to scan our model. But this is an item that's it's inside your own network. It's alongside your object storage. And basically when you make a request to it, it's going to wake up, scan the model, evaluate the security posture of it based on the policies that you've defined, and then send that to the Guardian tool, which is kind of a managed endpoint, which makes a decision and then gives you the ability to know if you want to go further with the model or not. Maybe you don't even want to store it in your model registry if it's failing that scan. So really quickly here, we'll run this. Now we can see really that we've defined this model as this S3 URI. We have a Guardian client here, this really simple Python SDK. I'll show an example in a moment in a GitHub pipeline of a different approach. But what we're going to basically do is scan the model. This is going to take just a few seconds. We're going to move the model from the system we have in S3 into the Guardian scanner, scan it, evaluate it, and get a response. And this is really limited by wire speed, basically. So if you're thinking these model files, you guys had mentioned the AV products that cap out at like 50 megs or maybe others. We're reliably seeing customers right now running models north of 100 gigs. And so having something that can like download in parallel and scan at scale is critical.
Why can it do that though? Why can't antivirus do that?
It's performance reasons, because most of them are like limited by the CPU and like the hardware of the actual machine itself.
Yeah.
And antiviruses specifically are meant to run in the background, so they don't want to basically slow down the person's computer by scanning like a huge file, because then the person using the computer would be like, screw this, I'm just gonna disable the antivirus because it's slowing everything down.
Is Guardian running on the computer itself, or is it running through a service?
Yeah, so this runs as a managed, basically Kubernetes deployment inside your environment, so it can scale up or down based on the demand that you're actually running. So it can handle quite beefy. Glad you knew the answer, by the way. And so now we can see, took roughly 20 seconds or so for this model. Really quickly, we'll look and see the response here. And what we're seeing is like, hey, Guardian, did evaluate this model. It was blocked, failed your organization's security policies. And if you want wanted to know more and see kind of this big blow up of exactly what was there, what we can do is kind of take a look at this JSON payload. And here, this is the kind of API response we'll give you for every model that you scan. So you can see the criticality, the failure count, links to learn more, and the ability to kind of go in and dig into the policies in their meat as well. This is the dashboard for Guardian. You can come in and manage policies immediately. We let you scope them to your first-party models as well as your third-party models. And with that, we have a whole host of these. So I'll take a look at some of the third-party scans here first, but you can check for things like if the model's in an approved file format. So we talked about safe tensors. That's actually a really positive one. You could gate for that. Maybe Onyx is, particularly other, reasonably good example with minor issues, but you can basically block models based on that criteria. You can also look at code execution at load time, and that's this holistic collection of a high number of scanners based on the model that you provide, and we're going to figure out which ones are needed to look for exploits that run at the model load time when you first fire it up, or when you're actually performing inference. And we allow you to kind of go in here, even licenses being valid for use, you could manage the open source licenses that you want to kind of gate models on, kind of coming into your system. But what I'd also like to show is this other use case that we talked about of scanning models before deployment. So if you think about your CI/CD process, and we really want to show that there are these automated pipelines. So these automated pipelines want to scan before a model is deployed. With this, what we're actually going to do is take a look here at a example inside a GitHub pipeline. So this is a PR where we kind of tried to tweak a light GBM model. What we wanted to then know is, okay, is this model healthy now that we've done this process? We have a new model ready to go out across all of our resources. Mm-hmm. Here we can see the pipeline actually executed. We did get a failure, and this is natively reporting, and it's actually providing some controls and teeth into your ML ops process to say, no, we're not moving forward with this asset. It doesn't meet our barrier of security. Right. And so here we can click details. If I was the SDE on this, I could click that, see the exact stage in the pipeline that failed. I can again see that same payload. I know I can go dig into Guardian now and really hunt to the root cause, see, was it a malicious internal actor who's now, altered this? Is it an open source change that's now introduced this dependency? But we're actively a part of your MLOps process, and we're really gating and providing those teeth and controls right there.
Right, so you can scan it before you deploy it, and you can scan it after you download somebody else's model too.
Exactly. And so when you're thinking scanning other people's models, that kind of gets into this third-party model concept. And these are really the kind of final two use cases we focus on. And the first one is really allowing you to kind of open up all of Hugging Face and other resources for kind of this democratization of AI. Like you said, you're either using kind of a managed endpoint from an OpenAI or an Anthropic or maybe Bedrock, for example, or you're having to download your own model, and you could get it from a variety of sources. You're doing fine tuning, you're tweaking it, and now you want to go run it. We think there's a really important question you have to answer first, which is loading and using this model going to cause harm to my system? And so for that, we wanted something that fit really closely with the workflow of a data scientist. So this other notebook example I have to show here, what we can see is I would like to basically download a model. This is the snippet of code you'd see right from Hugging Face. Here I have an endpoint. I put it in the demo just so we can see what it is. Normally, this is the automation you add is your SageMaker lifecycle policy. So all your users can do this. Once they've set this parameter, there's no additional code they have to tweak. They don't have to maintain this whatsoever. They copy paste, do whatever they want. When they run it, now they're going to see a failure pretty quickly here. So this is going to say, hey, there's a stack trace. If you're used to working in notebooks, you're familiar with stack traces when things go wrong.
Yes, very much.
And this is going to say, hey, it was blocked. If you want to learn more, reach out to your admins, the guys that like yourself understand the threats in play here and how you want to protect against them. Mm-hmm. And so we also give you the visibility, again, once in Guardian, to come back here, look at this and see those scan logs, dig into more information on them and see holistically all the policies that you managed, what was successful, what wasn't. And now you've fully integrated this end to end into your MLOps ecosystem.
Interesting.
And this is a very fundamental. I mean, this is step one as a security program for your AI environment, right? Exactly. This is the bare basics.
Right. Because why would the firewall for your LLM matter if your LLM already compromised your internal network.
Yeah, exactly. Like your model.
What do you care? You just got jailbroken.
The ship has sailed. Yeah.
We
So this is
that's
fundamentally like this is like the step one to like inject some security in like your AI data scientists like working environment. That's
exactly. The last kind of like use case that we had here was this like automated approval process. So maybe you don't want the users necessarily to like rely on security on the fly. Maybe you're taking the existing controls you've been doing for years with like Artifactory or other resources to bring in those dependencies and kind of keep them in-house. We have access to an API here. I'll save the demo time on this one. But the gist is that you can ask, again, like, hey, my users want these models. We can use this as an API to give you an answer of, is that model safe? And then broker that into your model registry. That could be things like Databricks' Unity catalog, SageMaker's model registry, or really any ML ops storage or model storage product you're using.
And it's another source of enrichment in terms of like your security program as well. If you have people constantly downloading models, you can push that into like a CM or whatever to enrich to add more security telemetry.
Right. Yeah. So when you're seeing that particular artifact get used, you now have a record of it. You can embed that within it. When you're looking at the kind of sophistication of what you've deployed and you're thinking about your comprehensive broader bill of materials, this is really important information to make sure that you have a record that you can attest to. And it's this is really important. I think you're also going to see in the future people blending, getting more rigorous with like model registries that can really understand the artifacts of what they're actually capturing and storing, not just these singular files, but more of the broader automation around it. But Guardian, again, we think is a really good first start for making sure that the models are safe to use and not going to necessarily cause harm or violate your security policies.
So where do you go to get more information?
So to get more information, you can go to protectai.com/Guardian. That has all the information on this product. You can also just go to protectai.com, see all of our tools there. And then I think this has probably been called out on your show a few times, but github.com/protectai. That's going to give all the open source projects we're working on. So model scan's really important. You guys have got your AI exploits as well. So a whole host of tools that you can dig into there.
Great. Awesome.